So far we have seen various techniques for finding the peak element inside a sorted array, right? Now let's quickly write the C++ implementation of it inside the project that we are implementing. So since it is our first searching specific problem that we are trying to solve, inside the searching folder whatever we have created for storing all the searching specific implementations, here let me just create another folder called practice. Inside this practice folder I will keep all our practice problems whatever we will be solving. So here let me just create a new file called find peak element.cpp. so the naming convention is completely up to you. Whatever the naming conventions that you want to follow, you can follow. I'm going with this sort of naming convention. So here let me just get the code that we will be using, which is nothing but iOS stream. Along with that, since we will be passing an array of values, let me just get the vector as well. Okay, along with that, let me just using namespace std. Okay, here let me just define a class find peak element. Okay, now here let me just define a public method. Here in the end we will be returning an integer, right, which is nothing but the index at which the peak element is available. So the return type will be integer, and let me just define in using binary search. Okay, along with that, what it will do, it will take a array of values. Okay, now here let's try to write the logic honoring all the scenarios. So as part of the first step, what I want to do is, let me just read how many values are there in the array so that we can handle the empty array and non-empty array scenarios. So as part of the first step, let me just read the size of it, and after that, if at all the length that we have got length that we have got is equal to 0, that means that array is empty. In that case we will simply return -1. If at all the array that we have got is not empty, in that case what we will do, as part of this specific solution, we will be applying the binary search to find the peak element. If at all, if you want the solution of various other techniques that we have discussed when we discuss the algorithms of this specific problem, you can go ahead and check out the codingpal.org. I will put this find peak elements problem in the description box, and you can go ahead and find the solutions for various other approaches. My ultimate aim is to implement this problem using an effective approach. That's the reason why I'm explaining the solution for finding the peak element using the binary searching algorithm. So as part of the binary searching algorithm, what we will do, we will basically take the starting index and ending index, and along with that we will calculate the middle, and we will do we will limit our search to only either left part of the array or right part of the array. So for that, let me just define a start index. Along with that, let me just define another end index. The end index is nothing but the last index that we have in the array of values, which is nothing but length -1. Along with that, let me just define one more variable, middle, and let me just initialize it with -1. Now what I want to do is, I will simply run a loop as long as start is less than end. What I want to do here is, I want to calculate the middle. Middle is nothing but start plus end divided by 2. Okay, now all we do is, if at all the value we have at this middle index is less than the value we have at middle plus 1 index. So remember, we have calculated the middle, so we have got the middle index. All we are trying to do is, if this middle index value is less than middle index plus 1th value, that means the value at middle index plus 1 is greater than the value we have at the middle index, right? So that basically indicates the larger value is there on the right part of the array. So to continue our logic on the right part of the array, what I will do is, I will simply start with whatever the middle that we have calculated plus 1. Okay, in that way this while loop will continue, and we will again calculate middle index in the right part of the array and our logic still continues for finding the peak element. If that is not the case, that means whatever the value we have at the middle is greater than the value we have at the middle plus 1th index. That means the larger value is at the middle index. That means whatever the left part of the array that we have will contain the peak element. So for that, what I will do is I will simply update the end with middle itself. Observe here, I have not updated end with middle minus 1. I have simply updated with middle itself, because whatever the middle that we are having is having the greater value. That means it itself could be the peak element. That's the reason why here I am simply updating the end with middle itself. So this is an important thing that you need to notice here. Okay. Once this while loop, completes its execution, whatever the start variable that we have, it will hold the index for the peak element inside the array. So we will simply return start here. Okay, so that is the effective way of finding the peak element index using binary search. Okay, now let's just try to create the main method and let's just try to see if it is honoring all the scenarios. So here, first of all, let me just define a vector containing integers. Let's just say 1 2 3 4 and 0 1 2 3. Okay, these are array of values that we have got. Along with that, let me just create the object of find peak element, and using that reference, let's just call the find peak element using binary search, and let's just pass array. Okay, along with that, whatever the value that we are getting, let me just store it in one variable, and after that let's just print it. Okay, now if I execute this, if I simply choose run code option, since we have installed code runner on our Visual Studio Code, if you observe here, the index that we have got is 3. If you observe here, there are multiple sorted arrays inside whatever the array of values that we have got, right? 1 2 3 4 is one sorted array, and 0 1 2 3 is another sorted array. As part of the problem description that we have got, we can either return the index of 4 or we can return the index of 3. Here we have written index 3. That basically means we have returned the index for the value 4, which is at index 3 inside the array of values that we have got. So whatever the array that we have passed, sorted array that we have passed, our solution worked perfectly fine. So to test another case, let me just remove second sorted part of the array and let's have only one sorted array. So if I run this code right now, see, again I have got index 3. Index 3 is nothing but the index for the value 4. Okay, so it is working perfectly fine even if we have only one sorted array in the array of values that we have got. Similarly, let's just try to test one scenario where we have only one value. When we have only one value, it itself is the peak element. So if I check it out, the output that we have got is 0, which is nothing but index of the value 1. And to test another scenario, let's say there are no values inside the array whatever I am passing. So in that case, if I run, I should get -1, which I have got. Okay, so whatever the solution that I have written, using binary searching, it is perfectly working fine for the scenarios that I have discussed right now. If at all, if you want more scenarios, you can go to codingpile.org and there you find more scenarios and you can evaluate this solution against those test cases as well. Okay, so once again, if you want to find out the solution for other approaches that we have discussed, again go to the problem link that I mentioned in the description box. You will find all other approach solutions as well using C++. Okay, so that's it for this finding of peak element inside the sorted array. I'll see you in the next one.